Your essential question for today is how do we solve equations with exponents? This next unit is going to be all about exponential functions. The last unit was about radical functions and radical equations and rational exponents. So we're just going to move and transition into a different unit now. We're still going to be talking about functions and graphs and all that and solving, but we're going to be looking at things called exponential equations. Now, let me give you an example of what an exponential equation looks like. We're going to start off with a very simple one. So this is an equation right here. You've got 3 to the x minus 6 equals 3 to the 2x minus 10. That's an equation because if you notice there is a variable there. The variable that you're asked to solve for here is x. So you're trying to figure out what x is that's going to make this statement true. The reason why this is called an exponential equation is because if you notice where that variable is, it's an exponent. It's up there. It's the power. Now, there is a thing, though. You do notice that there are two variables here. You've got an x over here on the left-hand side, and then you've got an x up here on the right-hand side. But the problem is I can't do anything to it just yet. The problem is because both of those are exponents. Now, this is what we're going to do for this. If you notice, whenever you have an exponential equation, whenever you have an exponent, say, for example, you have 3 squared. What this is called right here is the base. The base is that big number that's right there. My exponent, or power, is that superscript right there. So this is the base, and this is the power. What I want you to notice here is that they have the same base. And that's very important, because if they have the same base, then that means that they can actually cross each other out. So then what I'm going to have here is, because they're the same base, I can cross those out, and that would just bring down x minus 6 equals 2x minus 10. So again, what makes this problem so easy is the fact that they have the same base. And that's what we're going to start off with, that they have the same base. And when they have the same base, you can simply cross those bases out, and you're just left with the exponent. So you see x minus 6 equals 2x minus 10. And then you would solve this just like any normal equation. So I would first start off by subtracting x from both sides, getting negative 6 is equal to x minus 10, and then add 10 to both sides, so you get a final answer of x is equal to 4. But remember, at the heart of this, guys, is the fact that they have the same base. And because they have the same base, you can cross those bases out, and the exponents will drop down. Now, the issue is that not every exponential equation is going to have the same base. And that's why we're going to have to do one thing first before we can do what we just did, and that is get the bases the same. And so what we're going to do is we're going to use a chart that I have on the board that I'm going to use also on here to help us rewrite these bases. So that's your first example, but it was really straightforward, not too difficult. Here's an actual problem that you would see on a quiz or test, and it looks like this. Now, for this one, notice that it's still an exponential equation. I've got 3 to the x minus 6 equals 27. But there's one very different thing about this from the previous example, is that they do not have the same base. If you notice, this has got a base of 3 on the left, and this has got a base of 27 on the right. So unfortunately, I can't just cross these out because I want to. That's not what I can do. Instead, what I have to do is I've got to rewrite this so that they have the same base. And so what I'm going to do is I'm going to use my chart that I wrote up at the board. And I'm going to look at my chart, and I want to see where the numbers 3 and 27 are in the same row. So if you look up at the board, you notice that 3 and 27 are in the same row, in the second row. And if you look above the 27, y'all see that says x cubed. So I can rewrite 27 as 3 to the third power. If you don't believe me, just multiply. 3 times 3 times 3 is 27. Now, the other one, 3, you notice it's to the first, so you're not going to do anything to it. But you're just going to leave it 3 to the x minus 6. But that's your first goal, is use that chart to help you rewrite your two bases, or just one base. But you need to give them the same number. And now they have the same base, you can easily just cross them out, and that'll leave you x minus 6, and that's going to be equal to 3. And then you can solve this for x by adding 6, and you get a final answer of 9. So just remember, the first step, your first task, is to see if they have the same base. If they don't have the same base, you've got to rewrite your bases. That's your task, the first thing. Once you rewrite your bases, then you can maybe cross some stuff out and then go from there. But make sure you rewrite the bases first. All right, let's try another one. Here's the next example. Let's say that I give you 2 to the 2x minus 2 to the 2x minus 1 equals 8 to the x plus 1. Again, the biggest problem with this is the fact that they do not have the same base, right? This has got a base of 2, this has got a base of 8. So unfortunately, I cannot cross them out just yet. So look up at your chart and see that they both in row 1. In row 1, you see the numbers 2 and 8. So I'm not going to do anything to this 2 because it's still going to be just 2. But the 8, look above the 8, and you see it's cubed. So I'm going to rewrite that as 2 cubed. So here's what I'm going to have. The 2 to the 2x minus 1 stays the same. But this 8, I'm going to rewrite as 2 to the 3rd power, 2 cubed. And again, if you don't believe me, just do it. 2 times 2 times 2 is 8. Now, on your paper, to help us out, draw this in parentheses, 2 to the 3rd, and then put x plus 1. There's a reason why I want you to put those parentheses there, because it's going to help you remember to do something on this next step. All right, I'm going to change colors. Well, that's half your battle, because your biggest battle was making sure they have the same base. Well, now that they have the same base, what can you do with those 2's? Cross them out. That's right. Now, the reason why I made you draw these parentheses on the right-hand side is because I was hoping that if you remember seeing parentheses, you might remember the word distribute. So you see, I'm going to have to distribute that 3 to the x plus 1. So that's crucial. So I'm going to get 3x plus 3 over here on the right-hand side. On the left-hand side, I don't have to worry. It's just going to be 2x minus 1. But that's what I would get over here on the left-hand side, 2x minus 1. And then just solve for x. There's different ways you could do this. I'm going to add 2x to both sides first. Yes, subtract 2x from both sides. And so that's going to give me 1x over here on the right-hand side. So I'm going to put that over here. And so I have negative 1 is equal to 3x minus 2x is 1x plus 3. And then I can subtract 4 from both sides, and that'll give me, subtract 3 from both sides, and that'll give me negative 4 as my final answer. And that would be my answer for that. So again, just be careful. Make sure you write them with the same base, and then if there are parentheses there, make sure you distribute. Sometimes it might be one set of parentheses on the right, sometimes it might be both sides of parentheses on both sides. But that's how you would approach that problem right there. All right, for the next one, take a second and write this one down. All right, so for this problem, again, you would rewrite each one of these bases. So I'm going to rewrite 4 as 2 to the 2nd power, and then put that in parentheses, and that's going to be to the x minus 1. And then over here for the 8, I'm going to rewrite that as 2 to the 3rd power. And again, I'm going to put that in parentheses to help me remember I've got to distribute, and this is 2x plus 3. All right, once I've done that, now I notice that they do have the same base, so what I'm going to do is I'm just going to cross out those two bases of 2, and now let's just distribute, and so I'm going to get 2x minus 2, so 2x minus 2 equals, and over here I'm going to get 6x plus 9. And so then it's simple from there. You just solve this equation. So to solve this for x, I would subtract 2x from both sides. So I'm going to get 4x over here plus 9. And then to solve this for x, I'm going to subtract 9 from both sides. So I'm going to get negative 11 is equal to 4x. And then finally, to solve this for x, I'm going to divide both sides by 4. And guys, I wanted to show you in this, sometimes you might get a fraction, and it's okay to leave it as a fraction. So you get negative 11 over 4, and that would be your answer for that problem. All right, let's pick up with this one. So I've got 8 to the 2x equals 16 to the x minus 2. So again, I can't cross out the bases because one of them is 8 and one of them is 16. So I'm going to have to try to rewrite these two numbers. So I'm going to look, and I look up at my chart, and I do notice that 8 and 16, so 8 is going to be 2 to the third power. So I'm going to rewrite 8 as 2 to the third power, and then I'm going to put that in parentheses, and that's going to be 2x. And then 16 is on the same row, so that would be 2 to the fourth power. That's right. And then put that in parentheses, and then put x minus 2. And so again, that, in my opinion, that's the most difficult part. Make sure you get the bases the same, because once you do that, then it's just simply crossing them out, and then making sure you distribute. So here I'd get 6x equals, you have 4x minus 8, 4x minus 8. And then to solve this for x, notice you got 6x over here and 4x over here, so I'm going to subtract 4x from both sides, and so 6x minus 4x, that would give me 2x over here on the left-hand side, and that's equal to negative 8. And then to solve this for x, just divide by 2, and that gives my answer of negative 4.